to try and get our heads around the definition of the convolution, let's just work out a couple examples. So let's calculate t convolve t squared. So using the definition, this is the integral from 0 to t of, remember what we're going to do is we can call this one the first function f and the second function g. Remember the formula for the convolution is the integral from 0 to t of f of t times g of, I'm sorry, this should be a tau, times g of t minus tau, d tau. So integral from 0 to t, f of tau, so f is the function that when you put something in, it gives it to you right back again, right? F of t is t. So that means f of tau is tau. G of t in this situation is t squared. So g of t minus tau, right? G is the function that just squares whatever you put into it. So g of t minus tau is t minus tau squared. Okay, integral d tau. And to work out this integral, well, now it's just a regular old definite integral, right? This bound isn't even, it's not even an improper integral, like we're so used to seeing these days. It's a regular definite integral. So we just need to work out this integral, treating tau like the variable and treating t like a constant as far as the integral is concerned. So let's see. It looks like this is a polynomial, so maybe to work out this integral, we should just multiply this all out. We're going to get, what, tau times t squared minus 2t tau plus tau squared d tau. So integral from 0 to t of t squared. Why don't we factor the, oh no, that's not going to work. T squared tau minus 2t tau squared plus tau cubed. There we go, d tau. And now we can do the integral with respect to tau. So this is going to be 1/2 t squared tau squared minus 2/3 t tau cubed plus 1/4 tau to the 4th. And then for this whole mess, we have to go from 0 to t. Of course, when we plug in 0, we get 0, so let's plug in t. We're going to get 1/2 t to the 4th minus 2/3 t to the 4th plus 1/4 t to the 4th. So we're going to get some multiple of t to the 4th here, right? We just have to do some fraction arithmetic. So let's see, this is, we're going to need to have things in twelfths. So this is 6/12 and 8/12 and 3/12. So 14, 17. 17 over 12 t to the 4th. So that's the convolution of t and t squared. Okay, it's a little hard to know, just looking at this result, it's hard to have any intuition about what this is, what this function is telling you about t and t squared. But just keep in mind that, right, our interpretation of the convolution is it's some sort of continuous adding up of historical effects. So if you have some action that you're taking with strength given by this function, and the effect of something delayed by time t is given by this function, then adding up the history gives you this. Okay, for whatever that's worth. Let's look at another example. So convolution of e to the t and e to the minus t. So this is the integral from 0 to t of e to the t times e to the, and remember in the second function, that's the one where we put t minus tau. And again, I've made this mistake. This shouldn't be t, this should be tau. Okay, d tau. All right. To work out this integral, probably the easiest thing to do is just put these exponentials together. So this is integral from 0 to t of e to the, let's see, we have a plus tau minus t plus tau. So this is all 2 tau minus t up there. And now we can integrate. So we're going to get 1/2 e to the 2 tau minus t from 0 to t. Right, we need this 1/2 because if we take a derivative to get back to our integrand, we have to have 1/2 waiting to cancel the 2 that would come from the chain rule. And then we just plug in our bounds. So 1/2 times e to the, so when we plug in t, we get 2t minus t, that's t, minus, and now we plug in 0, and we get e to the 0 minus t, so e to the minus t. And if you look at it, this is actually hyperbolic sine of t. All right,